Well, welcome. You made it to the end, almost. We got one session left. Too bad it's the lousiest session at Summit, but I'm still glad you came. No, I'm picking. So, how are you? How many of you were here yesterday for my other session? And you still came back. Wow. Thank you. So this is a continuation of that. But that being said, if you didn't come yesterday, don't worry. You won't be lost, I promise. Even if you haven't done Python, just pretend like you did and go, yeah, I know how to do that. And we'll go through it, but we'll have a good time. Because today, we're going to take what we learned yesterday, and we're going to use it. We're going to build out a data model. We're going to take that data model and save the predictions out and deploy it to Azure. And then we can call that model that we've deployed to Azure as a REST service and use it like we were doing like an app. So we'll actually see how we can take a model that we've built, deploy it into production, and actually use it in production. And we'll do all the similar techniques that I do where I work. So it'll be fun. So to begin, this is the session you're hopefully signed up for. If not, you're already here, and it's the last one, so you might as well come enjoy it. I don't care about your cell phones if they go off. They won't bother me, but they might bother somebody next to you. So if you can just silence them or put them on stun, that'll be great. Anybody know that lady? I don't know her. She's very happy. I wish she was in my session because she's very happy. Explore all the things that PASS have to offer. Vote. If you haven't voted for the board, vote for the board. Vote for the people that are either male or female. Those are the ones that are great. But no, I guess I can't say that. I got to be honest because other people relate to how they want to be. So, but vote for the people that you like to want to vote for. They have all their bios up there, and you can and see who you like and vote for them. And then also get involved. User groups, 24-hour pass. Had a guy that came up earlier. It's like, hey, I saw your session at 24-hour pass. I liked it. And I'm like, oh, wow, you were there. Because it was at midnight. And I thought, oh, you must be from around another country. But he was actually down the street in the city over. And so he was up at midnight watching my session. So that was kind of flattering. And then we have other stuff. And volunteer. Get involved. I started out down there where you guys are. Now I'm up here speaking. And so get involved. It's kind of fun doing this. I like speaking. So thanks for coming. That's me. The thing you care about is right there at the bottom. We'll see if this little thing works here. Oh, not that one. Not that one. That one. There's the code. So that should be the right length. I know you can't quite see it here. I only had so much text to fit it in. But the slide should be up there, and that text will be there. It's on my GitHub. So just go to GitHub, search for Stat Cowboy, and you can find all the code. And the PDF of these PowerPoints should be up there as well. So all the code I show you today will be up there. Everybody with me? And then if you want to look at some pretty pictures, I have a few of them up there. And I do have a blog. And then follow me on Twitter. I tweet occasionally, usually once or twice a day. It's usually technical stuff or pictures of my Yorkie. And he's really cute. He's 3.5 pounds. He likes to wear clothes and costumes. So on to the good stuff. So everybody get the picture of the code so you can go download it. So what's the agenda? Just an introduction to Python. I won't go much into that. I kind of covered that yesterday, but some of you weren't here yesterday, so we'll just talk for 2 seconds about why I use Python. I'll just do another brief introductions to the IDEs and to Anaconda distribution of the Python language. I'll go into some data wrangling and some visualizations, just show you some code around how we can deal with data in Pandas, NumPy, matplotlib, Seaborn. These are packages for data wrangling and for visualizations in Python. Talk about functions and classes and objects. Just show you a quick demo of what functions look like, what classes and objects look like in Python, so that when you see them, you know what they look like. And then we'll do some data science modeling in Python. We'll build a model to predict wine quality of red wine. So we'll have a bunch of properties of the wine, and we'll predict what the quality of that wine is and give it a rating. And then we'll take that model and we'll use a product called Flask, which is a micro. I think they call it a macro service that allows you to serve up Python code as a web REST API. In Flask, and we'll deploy that as a Flask in either in a Docker container and also in a platform as a service through the Azure App Services. So when we build a model, we'll be able to save that model out, deploy it into Docker, also deployed into these app services, and then we can consume that model for further prediction. So the idea being is, hey, we took this data we had for wine, we built this model off of the classifications based upon these properties, and then we can take a new wine, test all these properties about these wines, and say, hey, what's this classification going to be? How good is this wine? Put those into our model, and it'll shoot back and say, hey, it's going to be about a 6, or a 5, or a 4, or a 3, or a 9, right? And so that's the idea, and I'll show you how to productionize that, and then you can just take this code and put your own data set in, put your own business needs in, and actually deploy that into Azure or into a Docker container, which is what we do these days in the real world when we're deploying models. And then a little, again, Python and Microsoft, I'll have a little brief section about that, but we'll kind of cover that the last half anyway, because we'll be in Azure and doing things in Azure. Sound like a plan? Is that what you signed up for? Cool. All right. Onward. So why Python? It's easy to write. It's the #1 language according to IEEE something E's 3, I think, E's. It is the most popular language out there probably for data science, for anything. It's #1, right? And it's cool. If you notice, if you've been to the keynote on Wednesday, they showed that little that Azure SQL database edge on a Raspberry Pi. And that thing's running SQL Server and ARM, but it's also running Python, and you're putting code. So you can start building these models in Python, deploying them to these edge devices, and have those models and predictions being run out in the edge where your stuff is. I work for an oil and gas company. We have hundreds of thousands of wells out in the field with lots and lots of data, and it's really hard to get that data back to the office or even to the cloud, but we want to run those analytics. Now, with things like Azure SQL Database Edge and Python, we can deploy these models out in the edge, run them there, and just send back the predictions or send back the results that we know, hey, there might be a problem here, or we can tweak this setting here and make this well produce better. So these were things that are really nice about Python being a compact language and why it's very popular. And plus, there's just a huge ecosystem. Lots and lots of people are building packages and things for Python. Actually, one package I noticed today when I was going through the demos, one of the dependencies is a package called It's Dangerous. So that's what they named the package. But it was a dependency for one of the packages you'll install. But it was kind of funny. It's like, okay, that's kind of funny. They named the package It's Dangerous. But there's a whole lot of people out there developing for Python. So we talked about Anaconda yesterday. Some of you weren't here yesterday. So I'll briefly want to cover it again. If you don't have a distribution of Python that you're using, this is the one I recommend. This is the one that pretty much everybody out in the community that's doing Python is using. It makes it very easy to manage your Python environments so that when you're coding, you can set those environments up with the right versions of packages, the right versions of Python that you need to do your code. I use Miniconda, which is this right here. It's done by Continuum.io, the people that do the Anaconda distribution. It's just a smaller subset of the whole big Anaconda package, and it works great for me for everything I need. I just need the Python code and the Conda manager, and Miniconda gives me that. And so you can just follow that link, click the download, and then install it. Just follow the prompts and install it. And the thing I said yesterday was just download the latest version that's out there. Whatever the latest version that's production, download it in 64-bit for your platform, whether it be Mac, Linux, Windows, and install it, because then if you do need different versions of Python, like if it says, hey, this is version 3.8, which is the latest one to come out, and you say, well, I need 3.6 Python, because that's what my packages require, you can still install Python 3.6 versions of environments to run with this distribution. So that was one of the things that was real confusing for me. It's like, hey, I'm trying to use TensorFlow, and at that time, needed 3.5, or 3, whatever it was, version. I was like, but this says 3.7, but how do I get this one? But it doesn't matter. You can install the latest version, and then you can create your environments to be whatever version of Python you need. And then finally, if you didn't come yesterday, get my slides from yesterday. There's like 4 more slides about Conda, about commands and different things that you can do in Conda. I left one slide from yesterday because I'm going to do this today and demo this. And what this is this allows you in Conda, once you set up an environment, and for those who don't know what an environment is, it's literally just a directory that has the Python executable in it. It has all your packages that you've installed in that environment in it, and that's what you're using to write your Python code against in your IDE or in a shell or wherever. You can clone that environment. So you can use this conda env export to export that environment to a YAML file, and then you can use the conda env create to create a conda environment from that YAML file. And the reason why I say this is because I'm going to demo. These chairs are in the way. Pardon. I'm going to demo this in a second, but when you go back to, this is my GitHub. When you go and download the GitHub repository, there should be a YAML file right here. So if you look right here, I created a YAML file called Summit 2019. This is a conda environment that has all the packages and things that I'm using in this environment, so that when you go to run the demo scripts I run, you can just use this YAML file, create your conda environment, and you don't have to worry about making sure you got all the packages installed. This will do this for you. One thing to note is if you look, these list the package names, and I'll zoom in real quick so you can actually see it. Notice like Flask right here, right? I apologize. Zoom it when I do, my mouse sometimes doesn't work with the thing. But if you notice line 21, it says Flask equal 1.1.1. That's the version of Flask package installed into this environment. The reason why I'm pointing this out is later on, when I show you how to deploy your Python code to Azure, there's a file we're going to create. It's called a requirements text file. And it's going to list the packages that we want to install in that environment out in Azure to run our code. And you put the packages you need in there and the versions you want. And you're like, well, how do I know the versions? Just go create a YAML file. You can look in this YAML file and see those versions. So a little homework. Remember this for about 30 minutes from now when we get to the point where we're deploying to Azure. And you say, hey, I don't know what package and what version. Well, this is how you know. Now, you'll see when I get to that point, I don't have all of these listed in my requirements. I only have a few, and I'll explain that when I get to it. But the good thing is if you need to know what, there's his dangerous. If you look at line 33, I wasn't lying to you, there's the it's dangerous package. But these are all dependencies. I only installed about 5 or 6 packages in this environment, but it lists all the dependencies that these packages use, and that's why all of these are listed in there. So, everybody with me? So, we'll run this in a second. I'll create the environment just so you can see how that's done, and so that when you get back and you want to run this code, you can just easily get started by just installing Anaconda, create the environment for my YAML file, and you'll be able to just open up Visual Studio Code or whatever IDE you want and run the code. So I talked about some packages later. I added a couple at the bottom, TensorFlow and Keros. These are kind of the 2 most popular. TensorFlow is written by Google. I don't know who writes Keros, if it's Keros or whatever. But Keros is a package in Python that runs on top of deep learning, things like TensorFlow, CNTK, Theanos, and PyTorch. And what it does is it abstracts a lot of the complexities of using these deep learning libraries like TensorFlow, and it makes it where you have like one-line commands. And I'll show you. I'm going to show you a deep learning model. We're not going to go into like how to do deep learning models because we can't do that in an hour and 15. But I'll show you one. And you'll see I'll use Keros, and it's where I can take one line of code of Keros, which might have been 2 functions and a couple lines of code in the actual TensorFlow package. But that's what Keros allows us to do. It's a high-level abstraction type thing that you can simplify the use of these deep learning libraries like TensorFlow or Theano or CNTK. And then you have a list of other ones. Pandas. We'll do a demo of Pandas, numpy. These are our packages that we use to bring data in Python and manipulate that data and wrangle that data around so that we can then go and build models with things like scikit-learn, scipy, or deep learning models using things like TensorFlow. Right with me? So these are just some packages that we can use to put in our environment. When you get the YAML file and you look at it, you'll see where most of these are in that YAML file, actually, because I'm using certain pieces of these in all of the code we use. So. Visual Studio Code, this is my favorite IDE. That's why I have it listed. I don't think I listed any other ones, in this slide deck. It's written by Microsoft. It's cross-platform, like there's a Linux version, Mac version, Windows version. It's very easy to use, and as of January this year, I really love it because it has this support for this Python interactive window. And what that does is it uses a Jupyter notebook, the IPython framework behind the scene. When you run your Python code, it runs it in that framework, and so it creates blocks of code and output where you can easily see what that code has been run, what the output is, and you can close those blocks of code. You can restart the kernel, and you can see the variables and all that, and I'll demo this some more. I didn't get to demo as much yesterday, so those of you that are here yesterday and you're here now, you'll get to see a little bit better demo because we're going to use this a lot today, Visual Studio Code, and we'll do all the demos in it. So we'll go a little more into how that works. And the last thing is make sure for those that weren't here yesterday, if you're using Visual Studio Code, if you want the nice syntax highlighting and all that in your environment, make sure you install the pylint package. But once again, if you take the YAML file I gave you, Jupyter's in there, pylint's in there, all the packages I use are in there. You can use that to set it up as a starter to get going. So I'll give you a good demo of how this all works. It'll just be a demo throughout the whole thing when we get to the demos about how Visual Studio Code works. And then Jupyter Notebooks. These are the two IDEs I mainly stay in outside of Databricks. I'm in Databricks. Databricks has its own workbook structure, but they work a lot like Jupyter Notebooks. It's web-based development. You have a cell which can have markdown. So you think of like HTML. So you can put a bunch of HTML markdown language to say, hey, this is what I'm doing. And below it, you can have the code and issue your code, and then the output will go below that. And then you can just keep interleaving and go through the code that way. And that's kind of what that, let me do this. There we go. That's what that is right there. You can see kind of like here's this part right here. That's a code, that's just a markdown block. And then like there, that's the actual code and the output below it, right? So I won't go into Jupyter Notebooks today. Just buy the recordings and you can watch the session from yesterday. Or if you go to 24 Hour Pass website, I did a shortened version of my session yesterday on 24 Hour Pass. I meant to say this yesterday and I forgot, but you can actually see that now. They have the video recording of the one I did at midnight in my house with my Yorkie sitting next to me, which was kind of fun. He got to be a part of the he wasn't in the presentation, but he was in my lap the whole time when I was giving the presentation. But you can kind of see all the, I went a little more into the tools. So if you want a refresher and you don't want to wait a month for Pass to get all the videos up, you can go to 24 Hour Pass, and I have a good demonstration of how to use all the stuff I did yesterday about Conda and installing Conda and using Conda and using the IDEs and Jupyter Notebooks. You can get that 24 Hour Pass video and see it. So Pandas. So I'm going to go, so we kind of talked about that, why Python, what distribution you use, Anaconda, what IDE to use. I mean, PyCharm is by far the most popular for people. I'm not telling you to switch. I did switch, but that's just my preference. If you like PyCharm, keep using PyCharm. Visual Studio Code is what I'll use today. And then next, I'm going to talk a little about Pandas and NumPys, and I'm going to just go into demos pretty much after that, right? So Pandas, it's a package in Python that allows us to do series, data frames. It's a way to get data in and out of Python. In your code. It's kind of the building blocks of a lot of data science stuff we're doing. So we're either getting a Panda data frame and doing our models on the Panda data frame, or we're using NumPy. And so NumPy is an n-dimensional array. The package allows us to have n-dimensional arrays. So we can have one-dimensional arrays, two-dimensional arrays, three-dimensional arrays. We can even build out five-dimensional arrays and things like that. But it's another way of getting data in. And we use NumPy a lot in the data science, especially like in the deep learning, because you think of like an image, right? And you're going to classify an image. Well, the image is, it's two-dimensional generally on a picture, but then you have a red and a green and a blue. Well, you have a NumPy array that has the red, that has a pixel. For each pixel, you have a value in that NumPy array. And then you might have another NumPy array that has those. And then we take those and combine those and start doing our classification in deep learning. So we use NumPys a lot for that, but I also use NumPy a lot. We'll see this in the demos. I use NumPys a lot because if I just have a lot of numeric data, if I just have a frame of numeric data like this wine data, I can put it in a NumPy array, and NumPys are so extremely fast. So Pandas aren't necessarily slow, but NumPys are faster. And so if I just have a lot of numeric data, I'm going to build a NumPy array, and I'm going to use that NumPy array to do my data models. So I'm going to demo these now. So this will give you, once you see the code, it'll hopefully give you a little better explanation and understanding of what pandas and numpys do. So, and like I said, I'm on slide 14 of 38, so, and like the last 10 are like past slides and stuff, so it's gonna be a lot of demos, so stick with me. So, can y'all see that in the back, or do I need to go up a text? I need to go up probably in the back. Can y'all see that text on the screen in the back? We're good? Like a little bigger? Okay, all right. So that's a little bigger. It looked smaller than it was yesterday. So in your downloads, you're going to have this red wine quality pandas numpy Python. And I'm just going to close this output right here. And first what I'm going to do is I'm going to import all the packages I need. So I have the pandas package, and I'm aliasing that as PD. So that way when I reference down there, you can see where I can just reference it as PD. I don't have to type pandas over and over again. I have numpy. I'm referencing that as NP. Seaborn and matplotlib are graphical packages to do graphs, and we'll go those. Some things about Visual Studio that I didn't get to show you yesterday, extensions. So if we go into the extensions, you can see where I have a lot of these enabled. So if I just type, so if you see right here, I have the Anaconda enabled. If you're going to use Anaconda distribution or use Visual Studio Code, I highly recommend you to do this, to install this one, because when you install that one along with the Python module, and notice there's like 400 Python modules. The one that I use, I'm not saying the other ones are bad, I just don't need it. I haven't needed any of them because I use the Microsoft one. Notice where it says this is written by Microsoft. Notice there's 13,162 downloads of this. So a lot of people use it. So I install the Python extension. And when you click on this, mine says disable there, but if I hadn't installed, it'll be a green box that says install. You just click it. You just click on the green box that says install, and the extension will automatically install. A couple other extensions I'm going to show you, we're going to use later. We're going to use the Azure App Service extension. That's funny. This one is going to allow us to deploy our Python code right to Azure App Service from Visual Studio Code. You're not going to see me, you're going to see me go to the portal once to type in a file there in the Azure portal, but everything else is going to be done in Visual Studio Code. And you're going to see how easy it is to deploy that to the Visual Studio Code. And then finally, we're going to talk about Docker later. And I have the Docker installed. So those of you who don't know what Docker is the best way to explain it is like a lightweight VM, right? And it can run in orchestrators like Kubernetes. So Kubernetes are really orchestration software that can orchestrate multiple containers. And the way we use a lot of this in data science is you might build a container that's going to have a model in it that you're going to consume. And if it has to scale out to lots and lots of users, you can have that model scaled out across multiple containers. And then Docker has, the Docker along with Kubernetes allows those containers to have load balance and failover and things like that to handle lots of load of your code. So these are the ones that I'm going to use today. So I just wanted to highlight those. I have some notes here to make sure I didn't forget any of them. Yeah, Python, Azure, Anaconda, Docker, we're all good. I'm going to go back to the code, but before I do that, I'll just show you this real quick. We'll do this later on, but this is the Azure. After I install the Azure extensions, I get this Azure button. Also down here, I have a Docker one. And so these are all the Docker containers that are running local on my machine. And then if you notice the other ones, there's like SQL Server, for example. So like in Visual Studio Code, you can go and make connections to like SQL Server. Since we're at PASS, and PASS used to stand for Professional Association for SQL Server, I figure a lot of you do SQL Server. But Visual Studio Code is a pretty powerful tool. It's not just for writing code. I mean, it's for writing code, deploying code, connecting to database. It's beyond just like a code editor and a debugger. It's a platform to write and develop and deploy your code. And I apologize for all y'all sitting over there. This thing, you're not going to see my ugly mug. I really should apologize to y'all, not to them. They're like, yeah, I'm on this side. That's if you want to know why there's so many people over there, they're very smart, and they went, if they sit there, you won't have to see them half the time. So I'm going to go back to the code. And notice how my page went wacky. If you notice before I had the Python code here, and I had this interactive window here. If you notice a little splitter up here, I can split it. I'm going to close this one, and I'm going to drag my, excuse me. I got to drag my Python window over there, and then I'm going to close this split. So now I have my split back. This is how I like to run it. I got my code here, and then when I run it, it's going to show up over here. Some things I want to point out over here are important. This X, what this X does is anything that's showing up over here, if I want to get rid of it all, if I click X, it just clears everything out of it. And this is what's running in that IPython, that Jupyter. This is what gives me this Python interactive, this Python interactive window is what gives me all that functionality. If I'm running something and it's taking too long and I want to kill it, I can hit the square here to interrupt it. And then if I'm like, all my code is racked up and I got variables that are bad and I fix my code and I just want to start scratch, I can click this little green recycle button here and it's going to restart my whole Python kernel so that I have a whole new fresh environment. And any variables or things I had there, objects will be erased. I can hit the X to close that. So since I just did that, we're going to do some things. So one, I'm going to go and I'm going to set a variable called CD that's just to the directory where my data is. And I'm going to click this little button right here. This looks like a little table. And what this is the variables window. And you can see now I have a variable there called CD. It's a string, 89 characters, and that's just the path to my code. I'm going to show you a little later how you don't have to hard code that path in the next demo. So I'm going to hurry up a little bit around this code. So variables are set up. We're going to load our wine data. So we're going to use the Pandas read CSV. We're going to load that in. You see it's loaded as a data frame. It's just a CSV file that's sitting in the folder. And then one thing I didn't show yesterday, I don't know, maybe I did. Now that since this is a data frame, it's a data type that allows me, that has like has a data viewer built into Visual Studio, and now I can see the data, right? So I can see I have all these columns. I can see here's the quality. So this quality, this is our predictor variable. That's what we're going to predict, the quality of the wine, and all of these numbers are what we're going to use to predict that quality. That's what we're going to do a little later on here in about 10 minutes. So if I want to print info about that data frame, so now I have this wine PD data frame. You can see right here, it's just telling me I got like 1,599 lines. It tells me non-null, meaning I have no null values in there, which is important when you're doing data models. If you have null values, they can skew your model and make your model messed up. Having that info lets me know that they're non-null, and it detected that they're all either floats or ints, right? So they're all numbers. If I want to get the first few rows, I can do the head. And I get the first few rows. I'm just going to move that in just a little. So you can see there's the first few rows. If I want to get the tail. So right now we're working a Panda data frame. Here's some sample. If I just want to take a sample of 5 rows, just to kind of say, hey, just grab me a random sample of 100 rows so I can kind of see what the data looks like, I can do that. If I want to describe it, I can describe it, and I get different characteristics around the count, the mean, the standard deviation, the quartiles, you know, the 4 quartiles, the max value. So I can kind of get a distribution of what my data looks like. If I want to remove null values, I can use this print statement, and it'll print true if any of them are null. Notice that it all says false. And I kind of knew that because when I did the info earlier, notice that remember it told me everything was not non-null columns, not null. Vice versa, if I want to print the ones that are not null, I can see they're all true. And then Pandas has this really cool thing where if you say, a lot of times what we do is if we have like 1 million rows of data, and let's say 2,000 of them have a few nulls in there, instead of necessarily do what we do in data science or in statistics, imputing variables. Like if I have a variable that's like the fixed acidity, which is a number, let's say I have 20 of them that are null, and the other 800 are not null. I can just compute the mean of the other 800, and then say, hey, these 20, you become the mean. And we do that sometimes. But other times, if we have millions rows of data, we might not care about the few rows that are null, and we just drop them out. And so you can take a Panda data frame, do drop in A, and now any ones that were null will be dropped out. We didn't have any nulls, that's why we still have 1,599 rows. So we're going to actually classify, well, that's a lot of wine. If I had to sell it 1,599 bottles of wine, it would be great, unless they all said, oh, I won't say, because you might like that wine. But so if I just want to extract one column, I can do double brackets, single quote, and that's going to give me this one column. If I want to extract from row 2, remember indexes start at 0, so row 2 is 1. I can use this I location. And what this is this comma separates row, comma, column, and then on either side of those columns, you can have a number, colon, number to say, hey, I want from this row to this row, comma, number, colon, number, to say from this column to this column. And there's a little example down right there of that. So I'm just saying, hey, give me from the second row on. And I'm just showing you this stuff, right? Like, not necessarily so that you know, hey, I want to get rid of row 1. This is how you can do it. These are just showing you how to use this. If I want to extract column 1 and 2, I can do it like this. And that's going to give me column 1 and 2. I'm just showing you how to use pandas, right? If I want to just extract the same 2 columns but use the name, I can use the double braces and do the names. Everybody with me so far? Everybody good? And then, like I said, if you want to say, in this case, I'll get the first 10 rows and the first 2 columns. I can do this. And there you go. There's the first 10 rows. See, 0 through 9, and the first 2 columns. So, we're good? Just want to show you how you can use pandas to do stuff. We're not done, though. So if I want to melt and gather columns into rows, I can use this melt function. And now it takes, and I get a record for every value. So those 1,599 rows, it takes all the columns, and I'll have a column that's the, excuse me, I went too fast. I apologize for scrolling too fast. I get the variable, which is going to be the column name, and the value. So I can just kind of like really pivot it. But you might say, hey, you know, we're not really want to do that. I might just want to pivot it. So if we remember what our data looks like, this will be helpful right here. And I apologize for this little small window. That's one thing I don't know how to make it pop out. I don't know if that's a way to do that or not. You notice our data, right? We have quality, and we have all these columns that are just numbers that are just properties of the wine, the alcohol, all that. So if I want to then say, hey, let's group it by quality and get the mean for all those wines, I can use the group by function in Panda and do that. So now I have, for wines that are quality 3, the mean of fixed acidity is 8.3. So then I can start looking at the data and start making inferences about, you know, what does that mean? So let's go over here to alcohol and look at quality. So the quality goes up. Wow, as the alcohol goes up, apparently the quality goes up. Well, I don't know, maybe they started with the low quality wines first and that were lower alcohol, I don't know. But and if you know anything about wine, Brix is the amount of sugar that's in a wine, and then when you go and you ferment wine and you put the yeast, the sugar is the fuel for the yeast to make it ferment. And so if you have more sugar, you end up with more alcohol usually. And so maybe that has something to do with it, I don't know. There's your wine. You can also, so that was the group by way, but let's say I wanted to pivot the data. I can use this pivot table function to say, hey, pivot this and do the columns I want to be the quality, and then do the aggregation function as the mean. And so instead of having it where I have quality as the rows and the columns are the columns of the values, I now just pivot it to have the quality as the columns and the values this way. Just showing you different ways to wrangle the data, right? Which? I can do that one, yeah. You know what you're saying? I can hide the what? Oh, the files bar? Oh, yeah, that's a good idea. Yeah. How did I do that? You're right, you're right. Thank you very, very much. I appreciate that. I totally forgot about that. No, thank you. You get lots of stickers up here. You get a magnet. If you see me afterwards, I got a magnet of these. You can have a magnet put in your refrigerator, and your wife's like, who's that? Or whoever your ex-significant other or friends are like, who's that weird cowboy? Why have George Bush on your microwave or your thing? Thank you very much. So yeah, I didn't even think about that. So right now I brought in, if you noticed earlier, it was the red wine data. So we also have white wine data. So I'm just going to do the same command, the read CSV, bring in white wine, and then we can do some concatenation. So we can concatenate like a union. And so we just say concat, we get a union, and then now I have, because these have the same number of columns and they're the same types, I can concat and union them together. Let's say I want to join the columns and to do a join. So just for the sake of demonstration, I'm just going to use that iLocation thing and say, hey, take the first 4 columns and join them to the last 6, 7 columns here, right? And so I'm just using a little trick here to say, hey, if I run this for you, you'll see where it's just going to grab the, excuse me, that's not going to work because of, it should have worked. Did I forget something? Oh yeah, the bracket. Excuse me, thank you very much. I grabbed that first bracket. That bracket's for something else. So I do like this. I really appreciate that. It's hard doing this sometimes. You can see where I just grabbed the first, 1, 2, 3, 4 columns, and then this should grab the next columns. I'm just doing this as a shortcut so I can demo. So I'm saying, hey, typically it might be you have a different data frame of something else that has columns and you want to join them together. But this is how we can do like a join. And then all it does is say this axis equal 1. Axis equal 1 says, hey, join like a column level. Axis equal 0 says union it, right? And it's just telling it how to join. And so when I run that, I basically get the same data frame back because I just picked all the columns, right? So, but if I had other data frames that are different types, I can join them that way. And then just for the sake of showing you how to do like left joins and right joins or outer joins, I grabbed a sample from the Pandas data frame. So I'm going to create a data frame 1 that has this L key and this value and this R key of the value. And this is going to show how to actually do a join. Whereas this one, this concatenation just says, hey, slam them together. I'm not joining. Whereas this one's saying, hey, put these together where they match, right? And so I create these data frames, and then when I run this command to do the merge, I get this where they merge. And it's just another way of doing it.
Quick question. Are you just hitting F5 to run that?
Shift enter. Shift enter. So if you remember so on that first slide, if you forget, the slide that says Visual Studio, it says shift enter on there. So if you forget when you go home, it'll be there for you. You have to highlight it. So actually, I don't have to, if it's one row, I can hit shift enter. If it's one row. But like, for example, because these are on multiple lines, I have to highlight it. It's not smart enough. So if I just did this one, I hit shift enter, I get a syntax error. It's not like R, like the lady that was here yesterday that did R with me. You can do control enter in R, and control enter says, hey, this is all one technical programmable line. It's smart enough to run it. Microsoft hasn't got there yet. And then finally, if you want to do another way of doing the union with the merge statement, you can do it like that. Is everybody with me so far? Don't worry about memorizing all this. You can download it and go, because we're like that. So we're going to go on quickly here. So I got what? About 40 minutes, right? So we can do some plots. So some things that are built into Panda Data Frame, I can plot a histogram. And you can see where it's calling matplotlib. So you can see from the fixed acidity, it's more along this way, so we got a nice skew, kind of like how you guys are sitting. So being a data scientist, statistician, I might transform this variable so I get a more normal distribution if I'm doing things like regression or things that expect a regular, expect a normal distribution, or we call it Gaussian distribution. So this is where these are important. Let's look at alcohol. What do we care about? No, most of our wines are on the lower, but these are the high quality wines down there, as we learned from earlier, right? I want to do a scatter plot. So if I want to scatter plot fixed acidity versus volatility, they have that built into the data frames plot scatter, and we can see we kind of have this, distribution that's kind of, normal, not really, because it just kind of has a shape. So when you're doing in statistics, when you're looking at data, when you do what you're looking for is interactions, right? So if you think about an interaction, if you have more money, you probably have more things, right? Or, and so an interaction is if you have more sugar in your wine, you're going to, like I explained earlier, you're going to probably have more alcohol. And so these variables interact. And what they do is they're looking for shape. And so if you see shape in that data, and you're doing things like regression or things that are what we call parametric models, meaning they expect your data to have a certain distribution, usually normal, you can do these scatter plots to see what those look like, to say, hey, I might have to transform this data, do a log transformation or things like that. We can also do correlation plots. And so these are kind of similar. So what this is doing is looking about how correlated variables are. So on a scale of -1 to 1. So the darker the color, they have a negative correlation, whereas the lighter the color up to this is a more positive correlation. And then this is the SNS stands for Seaborn. And Seaborn's a very, I like it for doing pair plots and pair grids. I limited it to just the first few columns because it takes a lot of compute power to do this. So that's why I limited it to the first 4 columns. But you can see where I get some things in the Seaborn that's really cool. Here's a positive relationship between fixed acidity, and I think this is like citric acid. Of course, if you have a lot of citric acid, you're going to have a lot of fixed acidity. But you can see this is a very positive relationship. That might be one of those things where if I was really doing a data model, I might pull one of these variables out because they might be what we call multicollinearity. I can't say the word multicollinearity, meaning they have a thing called a VIF, a variable inflation factor. But I don't want to get too much in the statistics. But what I want to point out here is these are the tools we can use to look at these interactions, how our variables work, so that when you start really learning the statistics, you're like, oh, wait, yeah, I learned that I need to look at the interaction of my variables, and I need to do this plot, the scatter plot between them. This is how you do it, right? So don't get too caught up on the stats. I have a master's degree in applied statistics. I spent 2.5 years doing that. I can't teach you in an hour and 15 minutes along with Python and how to deploy to Azure statistics, but I can teach you that these are important in the future when you start learning more statistics, if you don't know them now, why they're important. So one thing cool is if you see where these bars here, these are the histograms, because this is where fixed acidity meets fixed acidity. And so you can see this is the distribution. So that's why I like this. I get a histogram and a scatter plot with the interactions. And then if you want to get a really, really cool one, we run this one. And this is also through the Seaborn package. So everybody good so far? This will take 1-2 seconds to run. Anybody has a yes or no question? Yes?
How is the cell-based execution in Visual Studio Code different from Jupyter Notebook?
Say that again? So how is Visual Studio execution of the code different than Jupyter Notebooks?
Especially the cell-based method that you're
So the cell-based. So this question is how does this differ than Jupyter Notebooks at executing the code? In Jupyter Notebooks, each one of these blocks you would see, I would create a separate cell block for it, and I'd hit Shift-Enter and run that cell. But since I'm in Visual Studio Code, I effectively have to highlight the cells. The code I want to run is one time and hit Shift-Enter. Behind the scenes, Jupyter Notebooks on my laptop and Visual Studio here are running in the same Conda environment and the same Jupyter IPython environment. So I think that finished, and you get these really cool plots. So this is your histogram, and here's your scatter plots. And so this gives you the scatter plot, and then it gives you this kind of, I forget what they call this. It's almost like a heat map. And you can kind of see where, hey, I got this real density of where this interaction, but there's definitely between citric acid and fixed acidity, which makes sense, right? One's like a measure how much acid you have, and one's a measure how much citric acid you have, right? So it's like they definitely have a part of that, right? So we see how we do some cool graphs, right? So we got some of that. So now we're going to NumPy. So I'm going to load the same data, the red wine data, but I'm going to use the NumPy, and I'm going to use load text. And it's just going to load my CSV. And if you look, it's a CSV file, and the delimiter is a semicolon in this case. And I say skip rows equal 1. I don't want the header in this case, just because I don't need it for when I'm building my models. So now, and you can see here's the type. It's a NumPy ND array. If I want to slice this data up, so if remember quality was the last column, the 11th column, the 11th column, and then, or the 12th column. And then the other variables, the first 11 columns, are my predictor variables, I can use a numpy array. Now I have a numpy array called x. And if I click at my variables here, you can see I have a numpy array that has my 11 feature classes for my 11 predictor variables, my independent variables, the ones I'm going to use to predict my dependent variable, which is y. And we're going to see this when we build the data models, why we do this, right? Because we need to tell this is what we're predicting and this is what we're using to predict. So now we've seen how we can take a numpy array, in this case it's numbers, and split it out to now we have a y and an x variable to predict. If I want to create numpy's arrays from a data frame, I can do the exact same thing I just did. I loaded the data frame earlier. Remember a pandas data frame right here? I can just use this NP array and drop the quality column, because I don't need that one, and I say axis equal 1 because I want to drop it on the columns. And now I end up with the exact same thing that I got here, but I'm just building that array from the Panda data frame. Now we see where, and then I can build my Y like this. Everybody with me? Like I said, it's code. Code takes some time sometimes to digest, but the cool thing is you'll be able to create this. And then if I want to create a Panda data frame from a NumPy array, I can use the from records, and I can recreate that data frame from the record. Remember, I didn't bring in the headers? So if I want to add those headers back to my data frame, I can say df columns, pass in the name of all those columns, and it will add them to this data frame that I just created right here. And you can see that right there. There's the columns. So this is how we can create data frames from NumPy arrays, how we can create NumPy arrays from data frames, how we can merge together, union together, do some plots. We can also complete histograms in NumPy. But this does it at the number level. So if I want to create, so this is bin by 7, 8, 9, 10, and you can see there's 0, 7, there's 7, 8, 673, 9 of these bins based on alcohol, right? So you're kind of seeing the distribution. So we're actually creating an array of that histogram of the distribution. And then finally, the last thing I want to show you is, remember I talked about dictionaries yesterday, those over here, those that you want. We're not here. All a dictionary is a data type in Pandas that has a key and a value pair. In this case, the key is, in this dictionary, is the name of the column, fixed acidity, and the values is this list. And if you remember yesterday, I said, when I talked about dictionaries, I said you can use dictionaries because your value can actually not just be a number or a string, it can actually be a list or anything, right? And so I can create this line dictionary. You see it's a dictionary right here. Notice I can still click on this button and see that dictionary. And see how it looks right here? I'm going to convert that into a data frame like this. And so just so you can see all the code, I just picked a few things. I'm saying here's the data frame, use this dictionary. These are the column names to use. And so basically what it did is it pivoted that dictionary to create this data frame. So just giving you some tools. And we kind of use a lot of this in different things. You'll see in a minute. I picked the wrong thing, but it's, I think it's that one. And see there, it created that data frame. So that's how we wrangle in NumPy and Pandas data frames. So these are kind of your key components. Like this is how you get started. I got to get data in if I want to build a data model. So now we see how that works. Simple functions, this is from yesterday. It starts with the DEF. You give it a name. You can take some parameters. If your parameters have defaults to them, like that name equals none, it has to be after the parameters that don't have defaults. And then if you don't know anything about Python, because you didn't get to come yesterday, Python is all done through indentation. So you have the colon that ends the name of that function, and then you indent 4 spaces, because anything less is crazy, anything more is more crazy. No. You indent how many spaces you want. I just do 4. And so you type 4 spaces, and you say, okay, what do you want this function to do? In this case, I have an if statement, the if, and that with the colon, indent 4 more spaces. And then the way we know these if statements and these functions end is we go back to the beginning, or we go back how many spaces we went to indent, right? So this is how we create functions in Python. I was about to say pandas. In Python, classes and objects. I know you can't read, well, I guess you can read that text a little bit. I have a demo file of this, so you can do this. But we can create classes in Python. And so you can get a class, give it a name, and in this case, I have created a class. Look, you get to see my face. Hi. The people haven't seen me for the last 15 minutes. Don't want to get too close to that. That guy's getting nervous over there. He's like, oh, he's close to the speaker. He'll get the feedback loop. So I have a class called class database. Oh, not that one. That one. Class database. And it's got these functions. It's got this init. This is like, hey, when I instantiate this class, it's going to initiate anything in here. So I'm creating this instance name that I call instance that I'm going to pass in as variable. And I have a couple of functions, MS SQL and Oracle. If you call the MS SQL function of this class, the version I'm going to say is MS SQL version, and it's clustered because Bob Ward would like that. And so would Anthony and Hamish. Then if you say, hey, call the Oracle and pass in the name of that instance, I'm going to say, oh, it crashed, and call Larry. And if you don't know who Larry is, he's Larry Ellison, the guy that was the CEO of Oracle. He's no longer the CEO. He's like chairman or something of the board, but he stepped down. And then we can come over here, apologize, and then I can have this main function right here. And what this is the main function is what's called when I run, this is like one Python script. This is what gets called when I call this Python script, and that's called through right here. So if this is just, when you see this if underscore underscore name underscore equals main, this is saying, hey, you just executed the script. What do you want me to do now? This is kind of like trying to think what the main, like main in like Java or something. And then it says, hey, execute this main function. And the main function says, hey, prod equals instantiate a class to database. Call it prod and say prod.oracle. And then I say, hey, give me a dev database. And I want the name to be dev. That's what gets instantiated right there when I do that class. And then I say dev MS SQL, and I say give it the version of 2019. And then I'll run this code, and you'll see what it looks like. But now I can have a class and pass multiple things in. So like if I'm building out code and I want to do different ways of testing it, I can build a class, I can have these functions and different parameters, and I can make, and especially if a lot of reuse, right? If I'm going to create and do a lot of things I need to reuse, and throughout my whole coding thing with Python, I can create a class to do a lot of that stuff. And I highly recommend start using classes. Real quick question, but go ahead. Yes. So his question is that self always there? Yes, that self is always in that in these functions of the main class methods right here, right? Because you're passing that self into that. So that's how you write that syntax. Good question. So I just talked about them. Let's just get in the demo of building out some models, deploying to Azure, because we have 5, 10, 15, 20, 22 minutes, right? So I want to show you how this works. So we'll finish the slide deck real quick. So app services, it's a fully managed platform, web apps. It's platform as a service. It's a way to deploy Python to the app service in a very lightweight manner. And we'll do this. This is what we're going to do today. Azure Functions are even lighter weight microservices. We won't do this today, but it's another way to deploy Python into Azure and serve out these REST APIs and these HTTP endpoints. Databricks, this is a super scale, multiple clusters. It supports Python. They had several sessions on that, but we can do Python and Databricks as well and start doing things with Spark SQL and packages that do it Spark. And then there's some references, and do your evaluations, and thank that guy in the Seahawks jersey. So we're just going to do demos, rest of the thing, right? So real quick, let's click the thing over here that gives me my files. And I have the database class one here. I don't know why I put it over there. I'm going to close the numpy one out here. Here's just the class example. I'll just run it real quick for you so you can see what it does. And actually, I'll click this little X, and I'll close the variables right here. And I'll run this again. And you can see where prod is Oracle, and it's class called Larry, and then dev is MS SQL, big data cluster. I just create a different class, right? And so the idea here is we can create these classes to reuse, right? It's like any kind of programming thing. So let's close the class. I shouldn't have done that. And then we're going to go right in here to this right here. So I'm going to walk you through what it does. We're going to run the code, and then we're going to deploy it to Azure into a container, and we're going to do all that in 5, 10, 15, 20 minutes. I'm like a kid with a manual watching. 15. Can't do math. It's like it's funny. My wife teaches elementary school. Like none of them know how to use a watch that looks like that. So import OS. Remember when I did earlier, I had the CD equals some path? This is the way to do this. You take this settings file right here, and you create a variable called approot, and this uses the OS package that's built in Python, and you grab your dir name of like where your file is. So that's your root directory. And then if you want to create variables to other directories, this says, hey, create a directory from where I'm at to static, or if you had a different directory there. We're going to use the static one when we deploy to the function. You'll see that in a second. So this is what this settings does, and that's what I'm using in this file that I closed like a goofball here. So I'm just saying from settings. Settings is the name of that file, and it says, hey, bring in the settings, the stuff that's in the settings Python file, and import approot. Import that variable approot, and I'm going to use it down right here to read in that load text. Remember what we did earlier? To load that text file in to create my, in this case, a numpy array of my data. I'm going to do some packages. In this case, we're going to use numpy. We're going to use scikit-learn to do some random forest, do some of the metrics around like determining how our model ran. So I'm just going to go ahead and run these as we go along. So let's import our packages. One thing, the package I'll point out is 2 more up here. Let's split this out. Let's close that. We'll bring this over there. That's where it went, you dirty dog, over there. So, and I ran current file is what I did. And so we're going to stop that. We're going to reset the kernel. I didn't run my selection, so let's just start over real quick. I jumped the gun and ran like the whole file, so we're already going into our learning. So we're just importing our packages. A couple of pickle, what this pickle package is, when we build our model and we have our model, pickle allows us to save it to a binary file so that we can then take that binary file, read it back in later on to predict against new data. And then the XGBoost is just another package that's great. It's extended gradient boosting. It's another a machine learning model to use to build it. So we're going to do random forest, gradient boosting, and we're going to do an artificial neural net. That's a fully connected artificial neural net. So let's get our data. We got our data. And if you look, it's just the same data we had before. We're going to split it up. Remember we did this earlier, right? So I wasn't just showing you stuff that I made up in the NumPy demo, right? And then we're going to set a seed. And the reason I set a seed is because that way all a seed says is when you run your code, run it the same way every time, not so random, so that when I demo this percentages I think should be 60.4% accurate for the random forest and the gradient boosting. And that way when I don't get surprised when I run it and all of a sudden it says accuracy 22%, because it's going to randomly, because the way these models work, they randomly run, and so they generate slightly different outputs, so to speak, every time you run them, because they're randomized. By setting a seed, I can say, hey, don't randomize it. Seed it with this number, so that when you run this randomization, it's kind of it's like a hash. It'll run it the same way every time, so that when you demo it, don't put seeds in your code, is what I'm saying. Only when you're demoing it, like I'm doing. And then I'm saying a test site. So when we do data science, we do statistics, we split our data up. 70-30 is a good split. You might hear 80-20. As we get into bigger data, some people are doing 80-20. And so what we do is we say, hey, we're going to train on this 70 to build our model, and then we're going to test on the 30 to see how good it did. And then if it did good on the test, and it did good on the train, and things look kind of right, we can say, hey, this is a good valid model we can use. We can then go and publish this model. So I set a test site of 0.3, and then I'm going to use this train test split. This is built in the scikit-learn to split my data up. And so I'm going to take the X and Y. Remember, X is the first 11 columns that are what we're using to predict. Y is what we're predicting. And I'm going to take this seed so that I get them split up the exact same way every time. And then it's going to split them up by this test size here. And so what we end up with is, excuse me. If I get my mouse to cooperate. There we go. So what we end up with, if I look at the variables, is I end up with an X train that's got 1,119. This is the original data set. My train's got 1,119. My validation has 480. You'll hear train and validation. You'll hear train. You'll hear test. Just depends on how people named them. But now I have a way to split, and then I have my Y split up. So I have the same ones. And so when it did that split, the 1,119 that it split for X, it created the Y with those same rows, those values, right? Yes, sir.
So what is the validation set?
So the validation set is when you train your model. So you don't want to just train across all your 100 rows and say, yeah, this is, or all 100% of your rows and say, this is a good model. You split up 70%, you train a model, and you get a model, you say, hey, this is good, I got like 90 whatever percent accuracy or whatever you have. Don't say 90% is great, it's really what you need to do and what you're doing. But let's just, for sake of the fact that we're here, let's say we build a model, it's 92% accurate, we like that. And we did that on the training set. Then I go to the validation set and run it on there, and I see how well it did there. Because you might get one on the training set, and it can be 92% accurate. You run it on the validation, and it could be 100% accurate. And you might, ooh, that actually might not be good. It might have overfitted. Or you might run it on there, and in the validation set, it was 30% accurate. And you're like, okay, yeah, I did great in the training, but it didn't go out. And it's a way to split them up, and you randomly split them up so that you can train this. It's a way to say, hey, I built this model, it said it was 92% accurate, but I have this other data set that I can then go predict against it and see, hey, how did it really do? And then if those numbers are kind of similar, you know it's kind of okay. But if they're kind of skewed too high or too low, or and we don't have time to get into the whole statistics of everything, but you can then look at the different measurements you got out of the training and the validation. And when you get training on kind of how to predict that, look at that stuff as a statistician or a machine learning level, you can look and say, hey, am I overfitting or am I underfitting? You know, it's for really validating if this is a good model. That's why we split it. So we have our data split up between training and split. So we're going to pull in the gradient boost classifier. So I create a variable, and I'm going to call this XGB classifier class. And then I'm going to fit the model. I'm going to say use the training data set and fit the model. And so it fit the model. And then I'm going to take that model and save it out to a pickle file so we can use it later. And then I'm going to do the same thing. So I just built one in gradient boosting. Now I'm going to do the same data sets, and now I want to build one in random forest. So there's a random forest. I'm going to fit it. All a random forest is if you're familiar with decision trees are kind of like, it runs a bunch of things to figure out that, hey, starting with this variable, if it's less than 9, go here. If it's greater than 9, go here. And then it says, okay, on this side, if it's less than 9, for this other variable. And it makes this tree that you can walk down to get to the decision. And it's really good for business because you can look at a tree and say, hey, I built this model, it's really valid. The business can then look at this decision tree and go, okay, when it did this and this and this, oh, I can see this is how I end up with a good quality wine, right? Or if you're looking at sales, or if you're looking at something to do with your business, decision trees allow you to see that. All a random forest does is it runs thousands of decision trees and does an ensemble of them to figure out what the best one is. So we're in our decision tree, we're going to dump our file from there. And then we're going to load that. So now we have a random forest and a gradient boosting, and now we're going to load these files back in to this variable, the pickle files that we did when we loaded these, and we're going to make a prediction. So now we're going to start with the gradient boosting. We're going to say take the validation data set and predict against that, take the model we did on the training, and then predict against, use the validation data set to predict against to see how well it did. And I'm kind of shortcutting some of the stuff we do around looking at the training and the validation just because of time. And so I run that, and then I look at the accuracy, and if I remember right, if I print the accuracy, it's 60.4, right? And then I can then do some numpy. This is numpy. I can stack the validation data the independent data on the X against the validation Y. So this is what the real value was for the quality, and this is what we predicted. And so if I column stack that together, I can get this result to see how well I did to look at that. And so if I come right here and look right here, what you're going to see, even though it says it's 60.42, what you're going to see if I go to the last columns, and you see where it says it was a 6 is what it was, what the real rating was, and we predicted a 5. It was a 6, we predict a 6, a 6, a 7. So even though it's 60.4 because it's comparing 1 to 1, it's not that bad, right? Because it's not like it was 10 and it predicted a 2. It was like it was a 10 and it predicted a 9, or it's a 9 and it predicted a 10 or 8, right? So this isn't bad. And this is just for demo purposes, and I got to hurry because I want to show you the Azure stuff. Do the same thing with the random forest. And then this is the exact same thing I did for the random forest. Let me, I'll just run that. And the random forest was 60.42 as well. That's weird that it worked that way. It just did. I think it's just because the way the data is small it is. And then the last thing I did is I talked about decision trees. I just took the data and just gave you an example of how you can do a decision tree as well. I'll just run this real quick just so you can see what a decision tree looks like. But I'm just giving you a few examples of how you can build models, right? And then we're going to deploy this to Azure. And so then here's an example. So like this is where I can call the predict function, pass some values, and this tells me the value of this is 5. Like so this is taking the decision tree I built with these variables passed in. It says this would be a 5. This is what the prediction built. And then if you want to visually see the tree, we can use this graph viz and build the decision tree. And it's going to create a PDF file that we can actually visually see. And if I go right here, it should have opened it up, but for some reason it didn't. I have it right here. And you can see that this tree, and if I zoom in, you can see where it starts and says, hey, with variable at the top right here, it's saying if it's less than 9.85, go this way, and if it's greater, go that way. And if I remember right, this might be alcohol, and which would make, but that's how you see how that decision tree works. So this is, if you had data that your business is looking at, you can see this. And so we got 10 minutes. I want to get to Azure. So the last thing I have here is, I won't run this, but this is just an example of Kerosene Tensorflow. You can run this on your own of how to do like an artificial neural net. But I just wanted to give you a few examples. But so this is how we built the model, right? So we went to NumPy, we got a data set, we split it to X and Y, then we split to train and validation. And what we did is we saved out these pickle files, right? So I built this model, we're gonna assume this model's good. And now what I wanna do is I wanna build an application that can use this model we built to go and say, hey, I've got new wine that came in, I have all these values, I wanna classify that wine based upon these values, how can I do that? So what I'm gonna do is, make sure I didn't forget to show you anything in here. I didn't get to show you this YAML file on how to create the conda command, but really just open the conda prompt, type the command there, and you can run. Actually, what I can tell you is this. There's a text file in here that I put in here that has the setup right here. So I have the commands sitting right there to run them. So if you just open up your conda environment, you can run those commands. So what I'm going to do is I'm going to close this folder, and I'm going to open a folder that I did called Redwine function. And what Redwine function is, it's just a few files. Remember the settings file? This is showing me the settings. It's got a requirements.txt. Remember in the YAML file I said these are the packages I need? Well, these are the packages I need in Python for my application to run in Azure for this prediction. I need Flask. What Flask is that microservices that allows me to serve out this as a REST web API. I need NumPy, I need scikit-learn because the model I'm going to do is the decision tree one, and it was done in scikit-learn. I have a startup text, and all this is this is the name of this file. This is where my Python code is for predicting, and this is the name of an app you'll see in there when I open this file. Right here, I'll do that first. You can see right here, here's the Flask. I'm using Flask. Here's Pickle. This is going to pull the file in. Here's that app static. And what that's doing is static is from settings, that settings file. It puts this static web page here. And what this is static just has my, my Pickle data file that I outputted. This has my model stored in it that I'm going to use. So if I come back here, I then have my app. So that app name is defined right here. That's what is this startup command is. It's saying run this app in this file at startup. And when we deploy this this is what's going to get run, okay? And so, and then, like I said, the final thing we have is the requirement. So the requirements tell me what Panda package I need to install on my Azure app service. The settings is used just to set my environment variables. I need that to know how to get to that file. Startup is when I deploy this to app and the app server starts up, this is the command it runs. G-unicorn stands for green unicorn. It's this lightweight web app like runner thing to run this Flask app. And then finally, I have the code. And this code, I have app equals Flask. And then right above this function right here, I have app route equals slash. And what this is saying is at the root level of my web service that I'm running with this green unicorn, run this function. So if you go and call that web service right at the root, it's going to call this makeCalc function. And what the makeCalc function is doing is pulling in the pickle file I saved. I saved my model. And then it's taking JSON files. I'm going to show you the test file in a second. It's taking a request. I'm going to send it some JSON file. It's going to be the 11 variables that I'm saying, hey, here's the wine information that I want you to go and use to, thank you, she's giving me a 5-minute warning, to predict against my, what I need to predict against to get that quality. It's going to read that data in, and then it's going to print the data out. That's just debugging. And then it's going to create a dictionary for the results. It's going to create a numpy array of the data I passed in as this JSON. And then it's going to do the prediction. And it's this model predict, this model's coming from the pickle file. And then it's saying, hey, from the data I brought in, give me the prediction, and then send the results back as a JSON. So everybody with me? And then this app main, this is just saying, hey, when I run this, do the app run this Flask app. So we're going to deploy this to the thing. So what I need to do real quick right here is, I've already deployed this for you. I will show you how to deploy it in a second. I'm just going to start a new Visual Studio Code, because in the root back here of the presentation, so this red wine function is just a folder under the root, but so that because when I deploy this through Visual Studio Code, I want to be in that folder that I'm deploying. So I want to be in that red wine function. That's just, that red wine function folder, it's its own folder for deploying my code. I have this, so once I deploy this, I just created a Python file here called Flask test. I'm going to scroll this over here. And all it does is it sets up a URL. This is what I'm calling, if you remember in what I just showed you right here, because of the fact that my Flask app, this is Python code, is just slash, I don't have anything after the slash. I just go to the root. You'll find where you create like one file that might have multiple things. And what you're going to end up is you'll end up this above a function. And then you'll have another one that might be a different route and another function. And then that's when you call that to the URL, that's what it knows to call. So I have this deployed to Azure in an app. This is the app I deployed. Here's my JSON I'm going to send in. I'm sending in this dictionary. There's 3 things I want to predict. They have different values. I'm saying, hey, here's the header. The content type is JSON. Go make the call and give me back the data. Let's just go do this. And if everything works right and the demo gods are nice and happy and good, we will get back 3 values, which are the quality based upon those. And what I'm going to do right now in the last 2 minutes is show you how to deploy the app to Azure. One thing I didn't get to show you is the Docker stuff. But the cool thing about the Docker stuff is it's very simple. Install Docker. And then I created you a command file here while that's running. And this is like, hey, build red wine. And then run it and create the container to run it. And then if you want to see the Docker file, for those of you that know Docker, I don't have a lot of time to explain Docker in an hour. That's a whole other session. This is the file. I'm saying grab me the Python 3.6 small build of Docker. I've got this app directory which has my code in it. I copy it to this source. I do pip commands to install the packages I need. There's a requirements text, just like you saw in the other thing I did. I expose the port I'm going to look at, and then I run the command. I run my Flask run that came from right here in my source. And it looks very, very similar to the one you saw earlier for the app hosting in my Azure that I just showed you. The only difference is this one has this port number in this host because it's telling Docker to run on this port. So if those of you know Docker, that's there. But let's get back here to the Visual Studio Code, see if it worked. And I got a response back, and it says the top one is 5.1, this is 4.1, and this is 5.3. So let me show you real quick how to deploy that. So I'm going to open up one more Visual Studio Code. And I'm going to go to this folder called Simple Azure Python Function. It's just a smaller version of what I just showed you. This just says hello, pass summon attendee. It's got a Flask name. It's root. It's got the requirements. In this case, I just need Flask. I don't even really need Pandas, but I just put that in there. See it? I'm going to delete that because I want this to run fast. And then I got a startup file. In this case, it runs hello, the name of this file. And in this case, it's my app. So to deploy this, all I have to do is go to this Azure function and have this app service thing. And I have this little plus thing. And when I click this plus, and if you haven't signed in yet, you'll just see a thing that says sign in your Azure portal, and then you'll see this. So go to app service, I click this little plus, and I pick my subscription. And everything I'm showing you real quick is at this link right here. So if you open this very simple one and you go to this Python code, everything I'm showing you, there's a step-by-step by Microsoft. So I'm going to create an app, and I'm just going to say it's JBJ2 simple app. And all that's going to do is this app, when it runs, is return that name. But it's exactly the same. This is exactly the same things I did to build the wine prediction one. It's just I didn't want to sit here for 10 minutes letting it install the packages. So I'm going to call it that. I'm going to use Linux. And then I'm going to pick Python 3.6 because I'm running Python code. But notice all the other stuff I can run. And then it's going to go out, and it's going to go to Portal, and it's going to deploy all the stuff I need in Portal. And if you look right here, you can see now I have the red wine app that I did earlier. This is the one we're deploying right now. And this came up. I can view the output. I'm going to clip it. But what I got to do right here is after I have this deployed, I got to do one thing. I got to say what do I want to run when this app runs. That's that startup file, that G unicorn. I right-click on Application Settings. I say Open a New Portal. And we're in the last session, so if we go over 5 minutes, you guys are okay, right? So if we do, I'll show you the Docker stuff. I'm in no hurry to get out of here, so I apologize. I put this session together in 2 weeks. So they asked me 3 weeks ago, right before I was going on vacation, hey, can you do another session on advanced Python? So anyway, I went to the configuration. I right-click Open in Portal. Here's what it looks like in the Azure portal. I click this General Settings here. And this is all documented in that URL I sent you. And I have to say, what do I want to run when this starts? I just want to run that startup file. It has the command to run. And I save this. And when I save this, this now will say the next time this app service runs, it's going to run the contents of the startup.txt to work. So I save that, and now I have to deploy my code. So all I have to do is go back right here to here, and if I right-click and say deploy to web app, I say what I want to deploy. I want to deploy the simple Azure Python function folder. And this is why I opened up a new Visual Studio Code and went right in that folder. I just want in that folder only thing I need for this app. So I didn't do it from the main one that has a bunch of other garbage, right? And it says, hey, do you want to deploy this? It'll override anything. You say yes. And all this code's sitting out on the GitHub. And it's going to deploy this. It should go really, really quick. And then once it's done, while it's running, I'm going to go right here to here. And I'm going to go to Overview. This is the URL should be right here of this service. And if I say open a new link, we'll see if my app service is up yet. It's not up yet. Let's go back right here. So it's still running. I can click this output window, and I can see, hey, look, this is where it's doing everything. It's building the service. I can see it being run and being created. But how cool is that? We didn't go to the only way to do the portal is put the startup part, but we were able to create through the extension, that's that Azure App Service extension, create all these services in Azure, deploy our Python code to it. We don't have to worry about anything, really. So we're doing that. One thing we can do while that's running is you can say start streaming logs. So if I right-click on the app and I say start streaming logs, actually I don't want to cancel it just yet because it's still deploying. You want to wait till it's finished deploying that. What this streaming logs does is from the console, you can actually stream the logs from the Azure portal of what's happening in your app service. So if you're having errors, you can go right here, click stream the log service, and see the errors as they happen, right? So we're still waiting for this to come up. This is why I didn't do the other one. Can you imagine the other one that had like TensorFlow and all these other packages I had to install? But does it make sense what we did, right? In the other one, we created this, going back to the other one, we created this binary file that's our model. And we built the Flask app to be able to call that binary file in for a model. And we put some code to accept JSON of new parameters predict, and we created this REST API. And just to kind of go back real quick right here, this part right here, this is not how you would this is not a real application. You'd have web developers or whoever has your application divide a front end where you say, here's the values, go, and it calls that REST service, right? But I don't have time to create a web service. So if I go back real quick here, this should be done. We're waiting for a long time. While that's waiting, I'll do one thing. I'll go right here. I'll go to the Docker one. And if I go into this folder right here, and I say cd right here, and this is where my Docker file is, if I say deploy, you're going to see where it's going to build my Docker container. And so once I have this Docker container built, all this Docker container is, it's the same thing. It's the same Flask app, but it's running my Docker container. You might say, well, why would I use a Docker container over an app service? Well, if you want to have more control, you get more control with a Docker container than the app service. Also, if you need to really scale it out really big and have it go across, like using things like Kubernetes clusters and all that, that Docker container gives you that ability as well. So all this is doing is it's pulling down the Docker image for Python 3.6. It's installing all the packages I need. It's installing the Flask code and everything there. I'm sorry? The Docker container wherever you want. I'll show you in a second. I can push this Docker to an Azure container repository, and we can use it there. And so it finished. I hit browse website. Those of you who are walking out the door, if you look up, you'll see in a second it should say, there you go, hello, welcome, past Summit. So you see how to deploy that there. And then finally, real quick, we're almost done. What was I going to show you next? Streaming logs. So now that I can stream the logs now, if I come right here and I say start log streaming, this is going to restart the thing, and it'll stream those logs. And this is how I debug problems. And then, real quick, the Docker container's done. If I go and look at this deploy command file, once this is done, I went up in Azure, and I can train an Azure container repository. These are the commands at the end of that deploy command. You can deploy this Docker container now into your Azure container repository. From there, you can go to an Azure container instance, you can go to Kubernetes, Azure Kubernetes, or you can run your Docker local. And so my Docker is running local. This is the last thing I show you, I promise, unless you guys want to show something else. If I go back to my testing thing right here, and I change my URL to the Docker test URL, and I get rid of that, I save it, and I close that, and I run my current file. This should now be calling, there, see how fast it was, because that was local, right? And now it called my local Docker container. But I can run my Docker container local, don't do it on your laptop. Go push it to either Azure or go push it, like you might have Kubernetes or something, or you might have a Docker OpenShift or something, anything can run Docker containers. You can push this Docker container to that, and then you can serve it out. That is my presentation. I hope it met all your expectations. Please fill out the session evaluations. Be honest, this is literally the first time I did it. I've never run through it. I just put it all on my head and put it all on paper and did all this. Please be honest with me. Let me know what you like, didn't like, your hair needs to be a little less crazy, you're a little manic. I didn't get to see you enough because I was on the left side of the stage. And if you really did like it a lot, give me really good evaluations so that PASS will invite me back and I'll do more stuff. And like maybe next time I come back, we'll go more into the models and do more, and I'll do a more advanced. So thank you very much.